Hello, nice to meet you guys. I'm Engine from Group 8 and I will create out the experiment set for very training sample size. Okay, this is the agenda. So, our objective for this project is to predict the airline passenger satisfaction. Alright, since we want to predict the airline passenger, let us take a plane trip and fly in the sky to evaluate the model. Cheers! Okay, in a blink of an eye, we reach the sky. Oh, such a beautiful sky. Let me start with the experiment set 1. Okay, from the experiment set 1, we actually evaluate a few different machine learning algorithm and we managed to find that the decision tree classifier able to achieve the better result. So we will categorize this finding as model 1. Okay, when we go into the experiment set 2, we will continue using the decision tree classifier and evaluate all the features from the data set. Okay, and to find the best feature with the machine learning algorithms such as wrapper approach, filter approach, chi-square, and etc. So there are total 22 features and we managed to find the best 15 feature from overall features. Okay, so this finding will categorize as model 2. And then when we in the experiment set 3, we will continue with the decision tree classifier and examine with assemble learning to see whether the assemble learning can help to improve the model performance or not. So there are total 4 assemble learning such as bagging, boosting, voting, and stacking. And we managed to find that actually bagging assemble learning able to achieve the better performance. So we will categorize this as model 3. Okay, when we go into experiment set 4, we actually need to use 3 models that listed just now to examine if more training sample size will lead to better performance or not. So at first, we will use sklearn model section train test speed to split the training and test sample size into 80% and 20%. Okay, afterward, we will split the 80% of training sample size into 10 subsets with every subset contain 10% of training sample size to evaluate the performance. However, the test sample size will remain 20% and we will use it for the evaluation purpose afterward. Okay, so in fact, all the subset data is randomly generated and we have flipped the subset training data with the random state equals 1 to guarantee same sequence of random instance are generated for each subset. And we will evaluate the performance with every 10% increment training sample size until 100%. And lastly, we will evaluate the performance of the model with the 20% test set. Okay, so after we evaluate with the model 1, okay, this is the result how it looks like. We can see that in the chart is slightly overfitting when we use 100% of the training sample size, as the validation accuracy is slightly better than test accuracy. And then when we evaluating the model 2, the test accuracy is not good as model 1, but all the evaluation is well fit as most of the test accuracy is able to achieve better result compared to the validation accuracy. Afterward, when we evaluating the model 3, from the chart we can see that it actually achieved better accuracy when compared to model 1 and model 2. So in short, all the chart display with slightly upward slope. This can bring the meaning that by increasing the training sample size, able to achieve better accuracy. So overall, three model able to achieve about same accuracy with roughly 2 to 4% gaps only. Okay, so moreover, the model 3 with the assemble learning is able to achieve the better performance. So in summary, we can conclude that vary the training data set by using sklearn train test speed able to produce different results, and by using the assemble learning able to improve the accuracy, okay, when compared to the classification model machine learning. And lastly is we able to get higher accuracy of result when the training data continuous significantly increase. So now, after the evaluation, we're able to get to know that how to improve the airline passenger satisfaction. That's all my presentation. Thank you. Oh wait, what sound is that? Oh, plane is landing. Ooh, safe landing. Hope you enjoy the journey. Thank you. Bye bye.